Well, Mr. Sams, let's just start this right away. There's lots of cool demos.
That's right. This is why you take chemistry right here. This is
so cool.
This is one of my favorite lessons because
we get to burn things.
We do.
Oh,
this is what everyone thinks of when they think about chemistry: is all the chemical reactions.
So hey,
let's go.
Let's go.
Yeah.
Right. Hey, there are a number of different types of chemical reactions. Okay, there are combination reactions.
Yes.
Now, combination sounds like things that
combine.
together.
Yeah, these are sometimes called synthesis reactions.
Yeah. So actually, why don't you write that down? They're also called synthesis reactions. You're going to synthesize, make something.
Right.
All right. It's a general form. If you take a chemical A, react it with B, you make AB.
Right. So you take two things or more and smush them together into one.
Yeah, pretty simple. All right, here's a real example. If I take calcium oxide and I react it with carbon dioxide, it'll make calcium carbonate. This, by the way, is the stuff you find in bones or seashells. Your bones are made of calcium carbonate.
Marble.
Marble. Yeah. Okay. Or if I take mercury and react it with oxygen, it makes mercuric oxide, mercury 2 oxide.
Yeah.
Notice it makes one substance here. You have chemical A, you have chemical B, and you have chemical AB, if you will. Okay. Now, I think we should probably do a
video.
Yes, a demonstration, and I will put some things together and make them synthesized. Okay? All right, now we're going to talk about a combination reaction. A reaction where you have two things, and they're going to join to make one. All right, the reaction I'm going to work with is I have sulfur, elemental sulfur, right here, S. I think it's S8, isn't it, Mr. Sanders?
It is.
S8 doesn't say that. And I have iron metal. Okay, so what I'm going to do is I'm going to take into this test tube, and I'm going to put some of my sulfur. This is a one good thing of sulfur, isn't it, Mr. Sanders?
That is, but it smells lovely, doesn't it?
Oh, woo! Oofta! All right, so I have some sulfur in there, right? And then to that, I'm going to add some iron metal. Now, notice one thing I am doing as I'm mixing these. Notice I have different scoops for each of them because I do not want to put sulfur into the iron. It's not a good idea. Now, one thing I happen to know about iron, here, let me see, there we go, of course. So here is iron mixed with sulfur. Now, notice they're not reacting. They're just kind of mixed together.
Sitting there.
So I'm going to shake them up. Okay, mix, 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 mix. And they still haven't reacted. Now, one way I can know that is I happen to have a magnet right here. And if I take the magnet, I don't know if you can see this. I think you can. I can move the iron. Iron, of course, is attracted to the sulfur. And, yeah.
Attracted to the magnet.
Attracted to the magnet, yeah. So I can do that. The sulfur stays at the bottom. You can kind of see how the sulfur, because the sulfur is not attracted to the magnet, but the iron is. So now this is essentially just a mixture of iron and sulfur. So they have not reacted. So to get them to react, what do we probably need?
Heat it up.
We need some heat. So fire. All right, let me move things around for a moment. Okay. So we have our torch. Turn the gas on. Torch. So now I'm going to heat them up.
Pointing it away from people.
Not towards Mr. Sams, even though I might want to. And if you look carefully, you can see that there's actually kind of the sulfur slightly melts there, Mr. Sams.
I'm trying to zoom it in here without getting too close.
It's probably stinking up our room right now.
Yep.
We should have done this in a hood, Mr.
Probably
Sams.
should have, huh? Good thing we're the only ones here, huh? Ooh, that's pretty. Red. Yeah, that smells.
How long, Mr. Sams, do you think? Are we good?
Oh, I don't know. It's looking pretty reacted to me. There's still a little bit of sulfur at the top, but I think we're good.
All right. Now, if you zoom in, you can still see some of the swirling hot gases there, can't you?
That's, yeah, vaporized sulfur up there.
Yeah.
Lovely. I like that red. That's pretty cool.
It is cool. Okay, now here's the thing that's interesting about it. All right, if I take the magnet, now that the iron has reacted, it is no longer going to be attracted to the magnet. So as you can see, there's some that's attracted to the magnet. All right, that's probably because I was wondering it. I have to actually I probably didn't put enough sulfur in the reaction, but if I were to truly cause this to totally react, it would not be attracted to the magnet at all because I think I put too much iron in there. You'd have to figure out, actually it will teach you how you could figure out how much you'd want to add to it. But let's assume that I did. It would be unattracted to the magnet, which means you have produced something else, in this case iron sulfide, as opposed to just iron and sulfur.
It smells like I'm at Yellowstone.
Yeah, well, it's because sulfur stinks. I want to go put this in the hood.
Please.
That was so cool! It was amazing!
What did you have for breakfast this morning?
It was McDonald's. That is the problem.
I'm thinking
that
so.
McDonald's is bad for body. It destroys cells and brain cells, I think, too. Okay, that's a whole nother issue. Okay. Hey, we should actually talk, guys, about another combination reaction which is very famous.
Yeah.
And also very sad. This is the Space Shuttle Challenger.
Yeah.
And if you recall, many of you are probably too young to know.
I was in 2nd grade when this happened.
Okay, I was much older than that. Okay,
Yes.
but there was a space shuttle called the Space Shuttle Challenger, and in 1982,
Four. Three.
I was in college.
I can't remember. I was in elementary school.
1984. Yeah, that sounds about right. I was in second year college. About 1984, the Space Shuttle Challenger lifted off, and it exploded in the air, killing all of the astronauts. As it turns out, there was a leak. I don't know if you understand, but actually, let me go back here. That there's 2 tanks. You can only see 1 tank, but there's a big tank here, and this tank is filled with oxygen, and then the other tank on the other side is filled with hydrogen. Okay, there was a leak, and then the 2 chemicals mixed at the wrong time. That's actually what's happening. Is this is hydrogen and oxygen reacting, but they form water. It's a very simple reaction. Hydrogen plus oxygen makes water. But it also produces large quantities of energy. They mixed at the wrong time, and these are the somber pictures of what happened. These are basically the pictures of this exploding. And the problem, of course, is as you see this huge explosion, of course, there were people in there, and it blew up. So it was just a simple combination reaction that had tragic results.
Commander Dick Snowden, followed by Mr. Specialist Steve Russell, Ron McNair, pilot Mike Smith, followed by Krista McCullough, feature in space, Ellison Onizuka, and payload specialist Greg Jarvis.
T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Challenger, go with throttle up. Engine's beginning throttling down now at 94%. Normal throttle for most of the plane, 104%. We'll throttle down to 65% shortly. Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles, downrange distance 3 nautical miles. Engines throttling up, 3 engines now at 104%. Challenger, go with throttle up. Challenger, go with throttle up. 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
Go ahead. Flight GC, we've had negative contact, lost downlink. Okay, all operators, watch your data carefully.
Flight pilot until we get stuff back. He's on his cue card for report modes. Flight controllers here looking very carefully at the situation. Obviously a major malfunction. We have no downlink.
The guidance system showed that right SRB motion diverged from the orbiter and left SRB, indicating that the lower ET SRB strut was severed or pulled loose.
Here's some pictures again of it happening.
Oh.
And these are the folks who perished in there. Actually, an interesting story, if you don't know this, is that this was the first, they called Teacher in Space program. And this lady right here, she is Christina McAuliffe, something, yeah, McAuliffe, and she didn't make it. She was going to do some cool experiments. Actually broke the hearts of lots of elementary kids, like probably you, Sally.
Yeah.
You were probably one. And the reaction was simply H2 plus O2, and it made water. Actually, to balance this reaction, we'd have to put a 2 here and a 2 here, and these folks, they perished in the explosion. So kind of interesting sort of historical note, a very famous reaction that had tragic results.
Yeah.
Okay. All right. We should do another type of reaction.
Okay.
Okay. How about we do decomposition?
Decomposition reaction.
Decompose. I can
let's
decompose.
Watch
you.
a video again. It's Mr. Berkman again.
Actually, before we watch the video, should
Yeah.
we just learn what types they are, maybe?
Oh, sure.
Yeah, we should do that first.
Oh, yeah.
So in a decomposition reaction, you have one substance that turns into two or more.
Right.
Usually two, it could be more. So AB turns into A and B. So an example of that would be actually the reverse reaction, the one we just talked about.
Yeah.
Water can be decomposed into hydrogen and oxygen.
Yeah, guys, this is the exact reverse of a synthesis or a combination reaction.
Yeah.
If you flip it around, you have a decomposition reaction.
And the word decompose makes sense too, guys,
Right.
because if you think something decomposes, it breaks apart, breaks down. Like, yeah, okay. Or here's another one, potassium chloride, breaking down to potassium chloride and oxygen. Now, these are not balanced reactions, by the way, guys. We'd have to balance them. Some of these we've already balanced, so it's not that important. Now, I think we should do a demonstration. Video. Okay, so who's going to video us?
I think it's you this time.
Is it me? I get
It
to
is.
decompose and fire. I get to play with fire. All right, I want to show you today a decomposition reaction. Now remember, a decomposition reaction, you start with one thing, it breaks apart into multiple things. So the chemical I brought with me today is hydrogen peroxide, okay? This is the stuff that you can just buy at City Market or King Soopers or whatever your local grocery store is. I'm going to pour that into a test tube. Now hydrogen peroxide kind of by itself decomposes into water and oxygen gas. So it's actually decomposing right now, but it's a very, very slow reaction. So I'm going to add something to it that should speed up the reaction. This is not a part of the reaction, it's what we call a catalyst. And the catalyst we use will be manganese dioxide. So I'm going to get a small amount of this. Now, one of the products of this reaction is oxygen gas. Okay, so it's a little black powder. I'm going to put it right here. Because one thing about oxygen gas is that it's highly flammable. So I'm going to take a match and light the match, if I can light a match. And I'm going to light this little stick here, a wood splint, so that after this reaction takes place, where do matches go, Mr. Sams?
On the floor.
On the floor. Okay, it's the safest place to put them. So I'm going to add this. This should produce oxygen gas. And then watch what happens when I put this in here. See how it lights up much brighter? That's because we are producing O2 gas, and there's not a whole lot. See, it stays lit even when I put it in there because it's producing this oxygen gas.
You can even blow it out and make it glow and turn it in there. It'll turn back on or reignite. Hey, look at that.
There you go. See how that's pretty cool. Should do it again. Because it's producing the oxygen gas. And actually, this is a combination reaction and then a decomposition reaction at the same time. We're decomposing the hydrogen peroxide to produce the oxygen gas, and as I produce the oxygen gas, we're actually having a combination reaction, hydrogen plus oxygen makes water. So pretty cool. Oh man, that was fun, Mr. Sims.
Yeah, it stunk up the room. No, that was the earlier one. This
Yeah.
one didn't stink up the room.
Yeah, no, it was really cool.
Although
Yeah.
it still smells.
It does, yeah. Okay. Hey, single replacement. We should talk about single replacement.
We should.
Now, single replacement are interesting reactions. All right, let's learn about these. All right, this is an interesting one. You have A plus BC.
Mm-hmm.
So this BC will be an aqueous chemical, almost always.
Yeah.
And there might be some exceptions, but
Yeah. For our purposes,
for
they're
our
gonna
purposes,
be,
they will
yeah.
always be. So you've got some. Usually, it's an element. Actually, not it's an element plus some chemical BC, and it basically A decides he likes C better than B does, and B gets kicked out.
Yeah.
Okay, we'll use an
There's
analogy.
a
on that.
life lesson in here.
Yes, indeed. Yes. Okay. So here we have an example. If I take iron and I react it with silver nitrate, it's going to react, and what's happened is the iron's going to say, you know what, I like nitrate better than silver, and so he kicks them out
Yeah.
and says, sorry, you don't get to stick with
No.
nitrate no more. And then iron connects with the nitrate, and then the silver gets kicked out.
Yeah.
So yeah,
There it goes.
that's how it works.
Yep.
Okay, let's do an analogy, a little life
Okay.
lesson, Mr. Sams. Let's talk about a single replacement reaction.
Okay.
So let's pretend that. Did you go to high school?
I did go to high school.
Good. I'm glad.
Yes.
He went to college too.
I did.
All right. So let's say that Mr. Sams he took a girl to the homecoming dance.
Okay.
We just had the homecoming last
We
week.
did.
Yeah. So we have Mr. Sams, Mr. S, plus his date.
Sorry, it's the music of the dance.
He took, what do you think, Mr. Sams? All right, so we'll say S, that's you for Mr. Sams.
Okay.
And then we'll say C, your girlfriend was Cheryl. How about that?
Okay.
I don't know. Was she Cheryl?
No.
Oh, what was her name?
Girlfriend in high school. Gosh.
This is part of the problem. Okay, so he went to the dance with this girl. Okay, and let's say that just the most awesomest guy showed up. All right, he was just a really good-looking young man. And I don't know who his name is. Let's call him Frank for F, okay? What happens when we go to the dance?
Well, I'm guessing my girlfriend's probably going to say, see ya, I'm going to go with Frank.
Yeah, see, Cheryl really likes Frank, so she gets together with Mr. Sams and...
No.
With Frank, and then Mr. Sams gets kicked out.
Yeah,
it's
by
sad.
Myself.
Yeah.
Lonely.
So he gets kicked out.
Because I forgot her name.
This is a problem, Mr. Sams. All right.
I forget my own name half the time.
So, an interesting thing also that would happen, sadly, what happens if Frank took Cheryl to the dance and Mr. Sams showed up?
Not going to happen. No sweat, no change.
Yeah, Mr. Sams still gets to be the lonely guy. Why?
Yeah.
Because he...
the reaction only goes one way.
Yeah, Frank and Cheryl are a better couple than you would have been with Cheryl, sadly. Yeah. Yeah.
It's all right.
It's kind of like we call sometimes the attractability index, and Mr. Sams, as you can see, is not the most attractive man in the world, so... It's an analogy. Okay.
I'm married. It worked at least once.
Yeah, that's only got to work once. Yeah, that's true. Okay, I think we should probably do a demonstration.
We probably should.
So that you can get this idea and see what it actually looks like.
We get to play with silver.
Silver! Woo!
Okay, what I want to demonstrate for you now is a single replacement reaction. Now in a single replacement reaction, we start with an element. In this case, we're going to use copper, solid elemental copper, so just plain old Cu, solid. We're going to add that to an ionic compound. This is silver nitrate, AgNO3. Okay, so we have a metal ion and we have a metal atom. All right, so we're just going to pour some of this into our little dish here. Just enough to cover the copper. Stuff's kind of expensive, so we don't put too much in. And we're going to put our copper in here. Now this one doesn't react instantly, but in a few minutes you'll see that some silver is forming on the outside of the copper. I'm actually going to add a little bit more just to cover it all up.
It's kind of in the shape of a pumpkin, Mr.
It is. You know, it is the season. It's fall. It snows in the fall here where we are. So we had lots of snow today. Yeah, but you can start to see it's no longer that shiny copper color. It's starting to turn into kind of a darkish color. That's actually silver that's forming on the outside. What we're going to do is we're going to stop this. We're going to come back in a couple minutes. We're going to see what that looks like. All right, it's been about 20 minutes since we started our single replacement reaction. So let's take a look and see what we have here. So you can see that a lot of the silver that was in the dissolved solution in that clear and colorless liquid came out of the solution. It replaced the copper. So what it did is some of the copper that was on the copper metal became copper ions. And then the silver ions in solution became silver metal in the single replacement reaction. So you can see on here there's actually coated with silver. Ooh, you can see really well there on the back side. That's pretty cool.
Mr. Sams, why don't you put that on that little piece of paper maybe, and I bet it'll flake off. Just tap it.
Some of our silver metal there on the paper. Chunks of silver.
So if we were to collect that silver, Mr. Sams, we could make a ring out of it.
We could, or take it down to your local pawn shop and make some money.
Yeah, there you go.
In this economy.
There you go.
It's why silver nitrate's so expensive, because it has actual silver in it. So you have it. Single replacement. And we forgot to finish this one, actually. That was pretty cool.
That was cool, actually.
So you got just silver. Actual silver coming out of a solution.
So actually one thing that's very cool about these reactions is you tend to get these sort of precious metals in their pure form out. So actually maybe you're not so ugly after all. Maybe you're actually a precious metal.
I am a precious... Thank you, Mr. Bergman. It's kind of you to say so.
Yes, indeed. Okay.
Awkward.
No, I won't say that. Okay, the last one, no, not the last one, the second last one is double replacement reactions. Okay. This is sort of an interesting one too.
Yeah.
All right, we have AB plus CD makes AD and CB.
Yeah, so this, there's another life lesson in here, I think.
Yes, so A takes B to the dance.
Yep.
And C takes D to the dance.
Mm-hmm.
When they get to the dance, they switch partners.
Yeah.
They decide that they like the other person's partner and they switch.
Mm-hmm.
Mm-hmm. Yeah, so that's how that works.
Yeah.
So here's a classic example. If we have barium, he takes chloride to the dance. Sodium takes sulfate to the dance. When they get together, they switch. barium decides he wants to go with the sulfate girl, if you will, and sodium wants to together with the chloride girl, and they trade partners, don't they?
There they go.
Now, how you get them together and balancing, it's important thing. Some might say, well, why don't you write Na2Cl2 there, Mr. Sam?
Well, that's because we put them together the way the actual formulas form, and then we go back and balance them later.
Yeah, and we'll
talk
do
about that later.
In a subsequent podcast,
Yes.
but it's important to note that, okay? All right. So I think we should do a demonstration.
I think we probably should.
All right. So, Mr. Sams, you ready?
I'm ready.
Mix some chemicals and put them together into a very, very interesting.
All right, now we want to show you a double replacement reaction. So a double replacement reaction occurs between two ionic compounds that are in solution. So here I have a solution, meaning dissolved in water, of potassium iodide, Ki. Okay, you'll notice it's a clear and colorless liquid. Here I have a solution of lead 2 nitrate, also clear and colorless liquid. Two ionic compounds in solution. So what I'm going to do is I'm just going to add a little bit of lead nitrate to my beaker here. Okay. And then I'm going to add some potassium iodide to my beaker, and whoa! So our two clear and colorless liquids formed a yellow solid. Now if you get real close here, you can see that it's a solid that's formed. It didn't just turn into a yellow liquid. You can see chunks that are settling down to the bottom. We call that a precipitate. Now don't confuse that with precipitation, like rain coming down. This is a solid precipitate. So the solid precipitate comes out of the solution and settles down to the bottom. So two ionic compounds in solution, mix them together, and you form a solid ionic compound that does not dissolve in water in a double replacement reaction.
There you go, Mr. Sams. That was cool. So this is the reaction: lead 2 nitrate plus potassium iodide, and it formed
lead iodide.
Lead 2 iodide.
Yep. And potassium nitrate.
And potassium nitrate, yeah. Now, do we like to write it like this?
No, we usually like to write the symbols.
Yeah.
Because we don't like words with
Yeah, we'll teach you how to put all the symbols together in another podcast. This is just so you can identify and know which type is which.
Yeah.
Okay. Okay, so here's our example. Here's these two couples. They go to the dance, and what do?
They trade partners.
So this guy decides he likes her, or her. They switch, and then he likes her, and vice versa.
Yep.
Yeah. Okay. So that's how it's worked. All right. Fun activity in class? Yeah, we might do this just with them in class. Yeah, I think we'll do
Leave
it.
space.
All right, so leave some space. Hey, one last type. Combustion reaction.
Yeah, these are fun.
These are very fun. You get to burn things and burn things and burn things. In fact, we'll tell a story about how a student of mine almost burned his face off. Okay. All right, so here's the reactions. They will be a CHO compound or a CHA compound. It's a carbon, hydrogen, and possibly oxygen reaction, and it always reacts with
oxygen.
And oxygen always has a
O2.
O2, yeah. So watch that. And they form the same two things. These are the easiest ones. They always make the same two products, carbon dioxide and water. By the way, usually, because it's very high energy, these are both gases almost always. Yeah. Now, when I say CHO, this could be like CH4, C2H5OH. It could be C6H12O6. See, it has carbon, hydrogen, and oxygen in different ratios.
Yes.
So that's it.
But it all forms CO2 and H2O.
So here's, in fact, there's the CH4 plus O2 makes CO2 and H2O. In fact, that's the one we're going to use as a demo in just a couple of minutes.
All right.
Or we could have methanol. This is the one that set me on fire a couple of years ago.
Mm-hmm.
That was not a good thing.
No.
Yeah, that was.
You know those little fuzzy lumps you get on your sweater? You should probably take those off if you're ever going to be around fire.
Yeah, because they caught on fire.
They catch on fire.
Especially if you have methanol on you.
No.
Yeah. Very, very bad. Okay. Hey, I'm going to set something on fire. How about we do it now?
Let's do it.
I want to tell you guys a story. Interesting story. Many years ago, I was teaching at another high school. And when I was teaching at that high school, I had a student who said, Mr. Bergman, I wonder what this would do. And I about jumped out of my skin when he said, when I saw what he was about to do. I'm going to do what he was about to do much safer than he was about to do this. All right, I happen to have a gas jet right here, and this has got natural gas or methane gas coming out of it. I can turn the gas, and I don't know if you can hear, but it's now hissing. What the student was about to do is he had a, this is what he did, is he had a lighter. He was a smoker, and he was like this, and he says, Mr. Bergman, what would happen if I did this? And he had his face right in front of the gas jet, and he had his lighter. Well, I'm not going to put my face right in front of it as that student did. Luckily, I screamed loud enough. He did not do what I'm about to do. So we're going to do this on a much safer basis. So I'm going to light a match. I don't have a lighter, but I could use a lighter too. It doesn't matter. And I can go like that. And guess what? I can essentially make a flamethrower. Oh, it went out because it's just too much. Now, an interesting thing about this is right here, we're producing the gas, but it's not. Why didn't it blow up the pipes?
Because it's pressure coming out.
Well, it's pressure coming out, and also in the pipes themselves, there is no oxygen. The oxygen's only in this room. This is the type of reaction called a combustion reaction. A CHA, or a CHO compound, this is CH4, so it's a CHA compound, reacts with the oxygen, which is here in the air, to produce carbon dioxide, water, and heat. And I could warm my hands from this, or set my face on fire like that student almost did, but I screamed loud enough that he stopped.
Didn't you set yourself on fire a couple of years ago, Mr. Bergman?
I did, yes. That was it was a liquid. It was methanol, I believe, or ethanol. I can't remember which one it was. And that was a very unpleasant moment. Yes, I ruined my sweater, which was better than ruining me, so I guess that was good.
It was a bad sweater anyhow, wasn't it?
Yes, it was kind of nasty. Anyways, okay, so combustion reactions. A carbon, hydrogen, oxygen, a CHA or CHO compound reacts with oxygen. It always forms carbon dioxide and water.
Well, guys, that was very cool.
That was cool. You know,
Actually, it wasn't cool. It was hot.
It was very hot.
Yes.
When I was in 8th grade, the heat went out in the science wing in my junior high.
Okay.
In northern Wyoming, it was 30 degrees below zero outside.
That's cold.
It's really cold. So my science teacher went to the back of the room and turned on all the gas jets and lit them all and heated the room with the gas jets. But he like said,
science teachers
you don't
know
go
best.
to the back of the room, or I'll beat you to a bloody pulp so you don't burn yourself.
Nice.
Basically is what it boiled down to. That's pretty cool.
Very cool.
Mr. Keith, he was amazing. He
Yes.
was my inspiration.
Your inspiration. Nice.
Yes. I think we're done.
I think we're done. So that is the 5 different types of reactions. Now you're going to try and figure out how to identify them in your worksheets.
Yep.